Welcome to MrCScience.com's video on experiment 1.3. In this experiment, we're going to talk about concentration and show just how it affects, in this case, we're going to look at reaction rate. Concentration in your book is defined as the quantity of a substance within a certain volume. So what we're going to do is we're going to compare volumes and how vinegar reacts with an antacid and see what goes on there. So we're going to write this experiment up like we did the first experiment. So go ahead and either get a new sheet of paper, new document on your computer, or get your lab notebook, whichever of the three works. And go ahead and go to the top page. Okay, just like before, the first line will be our title, the title of the lab. So our title here is going to be concentration. Pretty straightforward. Next line, Roman numeral number 2, period, purpose. The purpose of this lab is to demonstrate concentration's effect on reaction rate. Reaction rate is just how fast a reaction occurs. We're going to watch a reaction between vinegar and antacid, which will bubble. It releases carbon dioxide, and those bubbles can tell us how fast the reaction rate is occurring. Okay, next one, Roman numeral number 3 is our hypothesis. Again, a hypothesis is just an educated guess as to what's going to happen. So eventually we're going to have a low concentration versus a high concentration. Which one will react the fastest? Okay. So our hypothesis is going to be a choose your own in this case. So a high/low concentration will react faster. Choose your own. What happens if you choose wrong? Do you get points off on your lab? No, you're taking an educated guess. Often you'll find the hypothesis is wrong. It just changes how we do our conclusion at the end. Okay, next one, Roman numeral number 4, materials. Again, we don't want to spend a lot of time going through all the materials, and since it's in your book, we're going to say as per text. Same thing with procedure. We don't want to spend a lot of time listing out the procedure since it's already listed out nicely in your textbook. So same thing, as per text. Again, if I'm going too fast for you, just pause the video, copy down, and continue on. Then Roman numeral number 6. Observations. This is where we record what happens, what we see. Okay. So what we're going to do in our lab is this. We've got 3 beakers. In those beakers, the first part of the lab says to put a cup. Well, we're going to do 200 milliliters of vinegar in the first one, 100 milliliters of vinegar in the second one, and 50 milliliters of vinegar in the third one. 50 should be, yeah, that should work. Okay, so let's go ahead and do that. Okay, our vinegar is pretty big, so I'm going to pour it into another beaker to make it easier to pour. Then we're going to use what's called a graduated cylinder. It's graduated not because it passed high school, but because it has marks of graduation along it. So first one, we want to add 200 milliliters, so I'm going to pour up to the 100 milliliter mark twice. Now in a graduated cylinder, there we go, 100 milliliters. $200 milliliters. Okay, that's pretty full. Now we're going to add 100 milliliters to this one, so just 1, Okay, and then we're going to add 50 milliliters to our last one. So in all three of these, the concentration is the same, even though the volumes are different. If we took a cubic centimeter of each one of these, a little block, and compared them, they would be identical. They're just all the same. So to these, we're going to add a antacid to each of them. So 1, 2, 3. I'm going to get the antacids out where you can see them better. And if I can't see it that way, I'm going to adjust a little bit further. Let's adjust a little bit more. So let's bring our video down. So now you should be able to see that each of those antacids is bubbling. You can see the bubbles coming up here, the bubbles coming up there, and there are bubbles here. It's just kind of off the side there. So they're all bubbling, and if we look at them closely, they're all bubbling about the same rate. So I don't see one going crazy and the other is not. So they're all bubbling away there. So let's watch that for a little bit and see what happens. So all these have same concentration, just different volumes, and they are all bubbling. So what will happen though is this one the antacid tablet may not be eaten up because it may react with all the vinegar in that smaller amount and stop bubbling before, and then that one would be second, this one would be third. Chances are this one will just be eaten up. So let's give it a minute here and see what we got going. Good, so let's record our first observation. Oops. There we go. It's not there. There, okay. In the different volumes, but same concentration, each beaker bubbled equally. Okay, that's our first observation. Okay, let's go back, take a look at our bubbling. So everything's clouding up, so it's harder to see the bubbling. But yep, everything's still going. This one's going pretty good. Yeah, it's all clouding up, hard to see on the video. I wonder if it'll look better without. I put the white under thinking that that might help, but what happens if we get rid of the white? Let me see here. Let's bring them closer. Okay, so you can kind of see a little bit. Here's the one tablet there bubbling. There's the other tablet there still bubbling. And where's our other tablet? It's in here somewhere. Oh, this one's so cloudy it's hard to see. It's in there. It might have already, nope, it's still going. So all the tablets are about the same size, all bubbling about the same. So now we're going to mix it up a little bit and we're going to change the concentrations. So I'm going to stop the video for a second and do a little quick rearrange. We'll be right back. Okay, I've cleaned everything up. Then I added 200 milliliters of vinegar to this beaker, 100 milliliters of vinegar to this beaker, and 50 milliliters of vinegar to that beaker. So just like our last experiment, all the concentrations are the same. Now we're going to vary the concentrations. What I'm going to do is I'm going to add 100 milliliters to the center beaker, thus bringing its total volume up to 200 milliliters, which equals the 200 milliliters in the other beaker, but only half of that is vinegar. The rest is water. So if half of it is vinegar, it's got half the concentration of the first beaker. So I'll add 100 milliliters here to bring that up to 200. And it'll kind of mix itself there, so not a big deal. Then this one, we've only got 50 milliliters. We want to bring it up to 200 milliliters. So we're going to add 150 milliliters to it. Thus, its concentration will only be a quarter of the first beaker. So here's 100. And now 50. Almost there. 50, there we go. Okay. So again, this is full concentration. This is 50% concentration. This is 25% concentration. Now if we drop our tablets in, this one bubbles, should bubble like the last one. There it goes, this one, and this one. Oops, missed entirely. There we go. Okay, so now if we move this one where we can see it, so we see that this one's bubbling like before, going pretty crazy. This one isn't bubbling as much. And then this one, you can barely see it bubbling. It is bubbling a little bit. So the higher concentration is bubbling faster than the medium is faster than the low. So if we watch this for a little bit, we should see the antacid being eaten up. So, yep. High bubble, kind of a medium bubble, and barely bubbling. So let's go record that in our observations while this is going. So, full concentration, bubbled a lot, 50% concentration, bubbled some. I misbubbled here. Then 25% concentration, bubbled a little. Okay, let's go back and look at our things here. So we see they're going to town here. This one's becoming very cloudy as it bubbles. This one clouding up a little bit. This one's still barely going. So we can see that difference in the concentration going there. I'm wondering if we let it go for a little bit, if we'll see differences in the size too. Let's give that just a little bit longer, and hoping we can still see this one as we go. We'll see. So what's interesting is our vinegar is actually already diluted. Vinegar itself, 100% vinegar, is a rather strong acid. What we put on our salads and eat is 5% vinegar. So that means that vinegar I put in there originally was 5% vinegar, 95% acid. So this one is 5%. That means this one's only 2.5%. And this means this is 1.25% vinegar. So, and the water won't react with the antacid, only the vinegar. So, basics of concentration. If you spread things out, it's harder to react because in order to react, the molecules have to come together. So it's harder for them to come together when there's less molecules around. So there we can kind of see our antacid still. Might see them better from the side. I'm going to try something here with my camera. We'll see if it works or not. Okay, so we got this. We got this. Okay, there we go. So you can see this one right here bubbling on the bottom. This one sitting right here is bubbling pretty good too, and this one is nice and easy to see. Let's move this one over a little bit. Let's see if we can. There we go. Let's bring this one over. There, now we can see it. And let's bring this one closer to the center here. There we go. Okay, now we can see it a little bit. See how big this one is? See how little that one is? This one's close, but it's a little bit bigger. So we can see the size as well. This one's getting eaten up really much faster than these. This is close to its original size still, so we can, that's another observation we can make. Let's go back to our lab. The tablets in the high concentration solution is being eaten up faster. Okay? Good observation. Let's see how we're doing here. So we're still bubbling pretty good over here. You can definitely see this one's smallest. That one's still going. And that's going. I'm going to pause the video and see if we can get a big size difference here. Okay, our high concentration one is getting so small that it's starting to get pushed around by the bubbles, and I'm worried it's going to just disappear pretty soon by wandering around. See how it moves around? So it's become so light that the bubbles generated underneath it can push it around fairly easily. These two are heavy enough that they're not really being pushed around. So, but yeah, you can see it's just getting eaten away, and pretty soon it's going to be gone. So, interesting thing why the tablet takes so long is it's got to eat the outside, and then it kind of works its way in, eats more and more, and so that's why it gets smaller and smaller. If you ground it up and put it in, one would react very quickly, the others less quickly, so, but it would be over very quickly then. So, yeah, it's getting pushed around there. Let's give it just a hair longer. I'm going to pause the video one more time. Okay, it's dissolving away to nothing here pretty quickly. It's going down. This one's kind of just falling apart a little bit from the being in the liquid, but it's not being dissolved as it's making piles. This one a little bit too. So, okay, so let's finish up our lab here. Let's go back to our lab. So next we're going to do the most important part of the lab. Why is it the most important? Because we're 50% of your lab. Roman numeral number 7, conclusion. Now, in this class we'll do almost all the conclusions by ourselves, but there will be times when I'll have you do a conclusion on your own. So let's talk about what we do in a conclusion. We restate what happens. So first thing we found different volumes did not affect reaction rate. Remember when we had the 200 milliliters, 100 milliliters, and 50 milliliters? Well, they all bubbled about the same. Different concentrations did affect reaction rate. The higher the concentration, the faster the reaction. Okay, so that's kind of a restating of what we found, what we saw. Another thing we do is we address our hypothesis. A low or high concentration will react faster. You chose between high and low. If you forgot to choose, you choose now, you get it right. But doesn't matter. So that affects our last part where we address our hypothesis. So we said the higher the concentration, the faster the reaction rate. So my hypothesis was right or wrong. Whatever, that's the only change to the lab. Whether it was right or wrong does not affect your grade whatsoever. So it's just whether you guess better or not. So real quick before we end here, let's go take a look at our tablet. Look at our high concentration one's almost gone. It's like smaller than an aspirin. It's tiny. So You can see high concentration, faster reaction rate, low concentration, lower reaction rate. If you have any questions on this lab, again, drop me a line at mrc@mrcscience.com. And if you wrote everything down just like we did, you may have to pause or reverse the video for a little bit if you need to catch up, but you got 100% on the lab, so good job. We'll see you at the next video.